Alright, so wrapping up this section, we're going to do quite a few examples here of multiplying polynomials. You just have to make sure to remember this one key, property, or this key rule, is that every term on the left must multiply every term on the right. So you have two polynomials, multiply them together. You must make sure every term on the left polynomial multiplies every term on the right polynomial. And this was determined using a repeated distributive property in the last video. So let's run through a couple examples. So something like a plus 5 multiplied by a minus 6. Notice in multiplication we don't usually write a symbol between the parentheses like we would with adding and subtracting. Okay, so now I'm going to multiply this. So every term on the left hits every term on the right. That means the a must hit both the a and the minus 6, so I'm going to write those out. That a times a is a squared. A times minus 6 is minus 6a. And then the 5 must hit every term on the right. So I'm just going through this slowly so you can see it. 5 times a is 5a. 5 times negative 6 is negative 30. Right? And so now we can combine the like terms. There are two like terms in the middle with the a's. Negative 6 plus 5 is a negative 1. And that should give us a final polynomial. All right? So again, every term on the left had to hit every term on the right. All right, we'll try that again. A few more examples. Let's do something like 2x plus 7 times negative x minus 5. Okay, a couple negatives in there. But again, I want the 2x to multiply both terms on the right. So 2x times negative x is negative 2x squared. Remember, with an x times an x, you add the powers to get x squared. Then 2x times negative 5 is a negative 10x. Then I need to multiply the 7 to both terms on the right. 7 times negative x is negative 7x, and 7 times negative 5 is negative 35. Then we combine the two terms in the middle. Negative 10 and negative 7 make a negative 17. And that gives us our final polynomial. Okay. Now again, I could expand this to much larger polynomials. Okay, so if I wanted to do something like x squared plus 3x minus 4 multiplied by 2x squared minus x plus 5, the same principle holds that every term on the left must multiply every term on the right. So the x squared must go all the way across here to all three factors on the, or terms on the right. So x squared times 2x squared is going to be a 2. The x squared and x squared, you add those powers, you get x to the 4th. Then you get x squared times negative x, that's a negative x to the 3rd, again adding the powers. Then x squared times 5 is 5x squared. Okay, not too bad. Now if I multiply the 3x, that has to multiply every term again on the right. So I get 3x times 2x squared is 6x to the 3rd. Notice I added the powers. 3x times negative x is negative 3x squared, again adding the powers. Then 3x times 5 is 15x. Now I'm running out of space, so I'm going to have to bleed this over to the bottom. I'm going to also go, the negative 4 must multiply everything here as well. So negative 4 times 2 is a minus 8x to the second. Negative 4 times negative x is positive 4x. And negative 4 times positive 5 is a negative 20. Okay. And now I just have to combine all of my like terms. Now, there's only one x to the fourth term. Let's see, I've got a minus x cubed and a plus 6x cubed. So minus 1 plus 6 is plus 5. I've got a 5x squared, a minus 3x squared. Combine those, I'm going to get a 2x squared. But then I also have this minus 8. So 2 minus 8 is negative 6. So that would be a minus 6x squared. There are two x terms, a 15x and a 4x. That would give me 19x. And of course, only one constant. All right. And that would be it. No more to simplify on that one. Okay. Quite a bit longer, but that's all right. Okay. Now the last thing in this section is going to be multiplying and when you have multiple polynomials together. So let's take a look at an example where you have a monomial, like 3x squared multiplied by a binomial, which is also multiplied by a binomial. So you can multiply in any order. Multiplication is commutative and associative, so it doesn't matter the order. And so I often do the binomials first and then bring the monomial in. That's just my personal preference. It keeps the exponents as small as possible. So I'm going to do that. I'm going to bring my 3x squared down. I'm going to perform this multiplication. X times x is x squared. Notice I put a parenthesis here. I'm going to group this together and then distribute in the 3x squared. So x times x, x squared, x times negative 5, 2 times x, 2 times negative 5. Okay. I'm going to combine the like terms in the parentheses. And then I'm going to distribute the 3x squared. 3x squared times x squared is 3x to the fourth. 3x squared times negative 3x is negative 9x to the third. And 3x squared times negative 10 is a negative 30x squared. Okay, that's our final polynomial. Alright, so the last example I'm going to run through is going to include 3 binomials, something like x plus 1 times x minus 2 times x plus 3. Okay, so 3 binomials. Now here you could take these again in any order. I'd probably just work left to right on this one. Again, making sure every term on the left multiplies every term on the right. So x times x is x squared, x times minus 2, 1 times x, and 1 times minus 2. Okay, that all gets grouped together. Oh, I didn't do my 1 times x and 1 times minus 2. I did them, but I didn't write the arrows. And then here I have an x plus 3 that also comes down. Now I'm going to combine the like terms here, x squared minus x minus 2 and x plus 3. And now I'm going to again ensure that every term on the left multiplies every term on the right. So I get x to the third, and then I get 3x squared. Then I have a minus x squared. and a minus 3x, and then a minus 2x, and a minus 6. Final step will be to combine all of my like terms. X cubed is separate. The x squares grouped together, I get 2x squared. The x's grouped together, that's a minus 5. And the minus 6 is all by itself. Okay? So again, we're just taking these two at a time. You start with two of them, multiply them together, simplify, and then take the other, or take that final product with the last binomial and continue to simplify. Okay, so distributive property all over the place, combining like terms all over the place. Right? Hopefully that gets you what you need for this section. Let me know if you guys have any questions. Email me, and don't forget to like and subscribe. Thanks. Take care.